Hello and welcome to yet another installment of the Algebra 1 videos. This is section 5 and this is a section called literal equations. And what we want to do is we want to rearrange a literal equation to highlight a quantity or of interest and use it to solve problems. So basically, when we have literal equations, we are solving equations that have no numbers, that have little or no numbers, that have pretty much only variables. Let's put that have only variables. Okay, and that's no numbers. Okay, sometimes we'll have numbers, but I just kind of wanted to go through something like this. So now, and down here it says a literal equation contains more than one variable. Okay, and formulas are typically literal equations, all right? And so, with a formula, okay, you can substitute your values and you can solve for the unknown quantity, okay? So there's two different ways to do it. Or, in a formula, you can solve for a specific variable and then substitute values and simplify. So this is a really important, algebra technique, and so, I want to make sure that we go through this. So on this, it says, we're solving a formula for a variable. So what I want to do is I want to solve the circumference formula for r to form an equivalent equation. So let's take this formula down here for circumference of a circle, and I know that the circumference of a circle is equal to 2 times the number pi times the radius of the circle. Okay, and if you take the radius and you multiply it by 2 and then you multiply it by pi, then it gives you the circumference, which is the distance around the circle. But what we want to do is we want to solve this equation for r. So solve for r. All right, so I'm just going to do the same thing that I would normally do when I'm solving an equation, and that's always just do the opposite. So what I have here is I have 2 times pi times the radius, and if I want to get r by itself, then what I would do, because I'm multiplying by 2 and by pi, then I would divide both sides of this equation by 2 pi. Okay? And over here, what happens is the 2's divide out, the pi's divide out, and you're left with this equation, this literal equation that says that your radius is equal to the circumference divided by 2 pi. Okay? And so this is my literal equation solved for r. Okay? And when I solve for r, it's r is equal to something else, all right? And so what we want to do is we want to find the radius, okay? So use the rewritten formula, this formula, to find the value of the radius when the circumference is 8 pi inches, 15 inches, and 24 inches. So 24 meters, all right? So what I want to do is let's first find the radius when the circumference is 8 pi centimeters. So let's do the first one here. Okay, so when c is equal to 8 pi centimeters, okay, then r is equal to what? Okay, so I'm going to say that r is equal to 8 times pi divided by 2 times pi, okay? And what I'm getting there, okay, what I see, and now I can just evaluate this for r, okay? And so I'm going to divide out the pi's, because the pi divided by pi is 1. And then I can simplify 8 over 2 to have r just be a value of 4 centimeters. And that's it. And I've just solved for the radius. And all I've done is take my circumference and plug it in for c of my formula, okay? Now let's do the next one. Okay, the next one is 15 inches. So on number 2, okay, when c is equal to 15 inches, all right, I'm going to substitute that in. Now I know that my radius is equal to the circumference divided by 2 pi. So I'm going to take 15, I'm going to substitute it in for c. So get that my radius is equal to 15 divided by 2 pi. So let's go ahead and do that in the calculator. I'm going to do 15 divided by the quantity 2 pi, and that's going to give me approximately 2.387, and that's in inches, okay? And so that's my radius when my circumference is 15, all right? So then, okay, let's do the last one. The last one is find the circumference, or find the radius when the circumference is 24 meters, okay? So I know that my radius is equal to the circumference divided by 2 pi. Okay, so I'm going to take 24, plug it in for c. So my radius is going to be 24 over 2 times pi. Okay, the 24 and the 2 can divide out into 12 over 1. So then my radius, r, is equal to 12 over pi. All right, and that's in meters. Okay, now, but if I wanted to actually get a decimal approximation for that, take 12 and divide it by pi in your calculator, and you get that r is approximately 3.1 or 3.82. Sorry, 3.82. All right. So either one of those works. Okay. So let's go ahead and take a look at this next one. Okay. Now, what we have here, in this instance here, okay, you're solving this equation for w. Okay, and so when you have this single variable here, you've got some value, 17 is equal to 2 times 5 plus 2 times w. And so then what happens is you get you get this value here of, you're just solving for w. So this is the same thing that you would normally do. So, but what we want to do is, solve this formula over here for w. Now, what you notice is that you have this is the perimeter formula for a rectangle, and you've got p is equal to 2l plus 2w. So what I want to do is just solve for w. Okay, so I'm going to move everything else over except for my w. Now I'm going to zoom in here. Okay, and the first thing I'm going to do is I'm going to subtract 2 times l. So subtract 2 times l. All right, so then I get this. I get p minus 2 times l. Now, I can't combine these. These are not like terms, okay? So I have to write it as the difference of two numbers, okay? And this is equal to 2 times w. Now, in order to solve for w, I'm just going to divide both sides by 2 and divide this by 2. And so I end up getting that, the 2's divide out here. So I get that w is equal to p minus 2 times the length divided by 2. So if I was given the perimeter and the length, okay, I could solve for w, all right? And that's all I'm doing. I'm just solving this equation, and this is my answer, okay? Again, like I said, these are equations that they have more variables than numbers, okay, more than one variable, all right? Now, on this one, okay, you're given this picture, and you're given the surface area of a cone is given by the formula S is equal to pi times the slant height L plus pi times r squared. And we want to solve the formula for this value here, which is L. So what I'm going to do is I'm going to take this formula, I'm going to rewrite it. S is equal to pi times the slant height plus pi times your radius squared. Now, what I want to do is I want to solve this equation for L. So I'm going to move everything over except keep my L where it is. So the first thing I'm going to do is I'm going to move this term right here, this pi r squared. And so if I subtract by pi times your radius squared, subtract by pi r squared, then my next step is going to be S, my surface area, minus pi r squared is equal to pi times the slant height L. Now, if I solve for the slant height L, then all I want to do next is then divide both sides by pi. I'm going to divide the whole thing by pi. All right, and the pi's divide out here. And so then L is equal to your surface area minus pi r squared all over pi. Okay? And so if you were given the surface area of a cone and the radius, you could use this formula to solve for L. All right? And that's all I've got. Okay, that's all we're doing. All right, so let's jump in here and use the same the formula that we had figured out on the other one, and we're going to do this two different ways. Okay, so we say we have a rectangle with a perimeter of 17 feet. So I'm going to jump in here and say that my perimeter P is equal to 17, and I have a length of 5 feet. So my length is equal to 5. Okay, and so what I want to do is I'm going to do method 1, where I use this formula here. So I'm going to do method 1, where I'm going to substitute in 17 for my perimeter, and that's equal to 2 times 5 plus 2 times w, okay? And what I'm going to do is just do this. I'm going to do 17 is equal to 10 plus 2w, and then I'm going to subtract by 10 on both sides, minus 10, and then we're going to get that this is 7 is equal to 2w. Okay, divide by 2, and we get that w is equal to 7 halves. Okay, now I'm going to use in the other method, okay, in method 2, I'm going to use the other formula. So this is method 2, and so I'm going to write out the formula. I know that p is equal to 17. I know that my length is equal to 5. And so I have the formula w is equal to p minus 2l all over 2. Okay, so watch what I do here. All right, and if I'm looking for my w, my width, okay, I'm going to plug in my perimeter, which is 17, minus 2 times my length, which is 5, and then I'm going to divide all that by 2. And all I have to do now is just evaluate this. So now I've got this. I've got w is equal to 17 minus 10 all over 2, which is going to give me 7 over 2. Okay, and this is the same number that we had on the other. Okay, these are the same. So it doesn't matter which way you do it, guys. It's just that this is another method. And a lot of times, you know, when you get further on into mathematics, solving a literal equation is going to be very beneficial to you. Okay, so, okay, on this one, it says the formula to convert Fahrenheit to degree Celsius is given by this. Okay, C is equal to 5/9 times the quantity F minus 32. And what we want to do is we want to solve this formula for F. So we go the other way. So if you're given degrees Celsius, then you can convert into, this into, what's it called? Fahrenheit. So what I want to do first, okay, and it's kind of unorthodox, but what I want to do is I want to multiply, you know, instead of dividing by this fraction, I'm going to multiply by its reciprocal. I'm going to multiply this by 9/5 on both sides, so times 9/5. Okay, and what happens here is when I'm multiplying this here and this here, when I'm multiplying all these things together, then I can divide things out. So I can divide out the 9s and divide out the 5s. So then what you have then is you have 9/5 C is equal to F minus 32. And then to solve for F, all I want to do then is add 32 to both sides. And then as a result, I get that my degrees Fahrenheit is equal to 9/5 times degrees Celsius plus 32. And that's it, okay? And that's all I'm doing. So, you know, it takes a bit of practice, but, you know, you guys will get the hang of it. Okay, now I want to take a look at something like this, okay? And what I want to do is I want to solve this equation for x. Now, I'm going to go ahead and subtract both sides by 5x, okay, minus 5x, and I get that negative 3 is equal to, and we can combine these as like terms, okay? They have a common variable of x, and I can combine 2 and negative 5. So 2 minus 5 gives me negative 3, and this gives me negative 3x. So then if I divide by negative 3 and divide by negative 3, those divide out, and I end up getting that x is equal to 1, okay? Now, I have a very similar equation over here, okay? Same form, it's just that I'm dealing with letters as my numbers instead of, you know, numbers, okay? I've got variables, all right? Now, what I want to do is I want to be able to solve this equation for x. So now, let's do this. Let me go ahead and subtract the ax from both sides, get the x's on one side, okay? And I get negative b is equal to c times x minus a times x. Now what I can do here, this is where it gets a little tricky, but I'm going to do this thing called factoring, okay? And factoring, and I want you to write this out over here, factoring is the opposite, okay, the opposite of the distributive property. So opposite of the distributive property, okay? And so what I can do is I have a common factor of x. I can factor out a common value of x. So I get minus b is equal to x times the quantity c minus a. So what I could then do, all right, is that I have this quantity, and this is where it gets kind of tricky. This question might be a little tricky for you guys. But I can then divide both sides by the quantity c minus a, and divide this side by the quantity c minus a. All right, typically, in the other example, what we had done was we had combined these two. But when I don't have numbers that I can combine, I have to kind of do a little bit of weird algebra. And this is where it gets kind of tricky. Now what I can do is I can divide c minus a by c minus a, and that goes away. So the equation then, solve for x, is that x is equal to negative b over the quantity c minus a. All right, and that's my answer. Okay, so it's just something that you do a number of times is just kind of tricky. All right, so now, all right, let's take a look at something else. Okay, over here. On this one, we want to just solve this equation for a. So here's my a. I'm going to leave it where it is. I'm going to move everything else to the other side. So I need to move the negative 8b and the 2 to the other side. So the first thing I'm going to do is I'm going to add 8b to both sides. Okay, add 8b. Now the next step, I'm going to write positive 2a is equal to 6c plus 8b. All right, now none of these aren't like terms. I can't combine these. All right. I can't even factor out a common value because I have a different value of c and then b. Now, if I divide both sides by 2 and by 2, okay, then I get this. Then I get a is equal to 6c plus 8b all divided by 2. And that's my answer. Now, I can rewrite this, and I can separate this out and simplify it even further. So you can simplify. All right, and what I can do is I can rewrite this and say, all right, well, instead of writing this over one common value, I can rewrite this as the sum of two fractions. So I can rewrite this and say that a is equal to 6c over 2 plus 8b over 2. Okay, so then I get that a is equal to, now 6 divided by 2 is 3, so this becomes 3c, and then this is plus 8b over 2, 8 over 2, okay, this simplifies to 4, so this becomes 4b. So a is equal to 3c plus 4b, all right? And that's it, okay? And that's it for this section, okay? Kind of a short section, but, it might be kind of tricky, and I want you guys to practice, and we'll practice in class. So thank you, and we'll see you soon. Thanks. Bye!